My name is Emma Taylor. I am in Physics 2, and I chose to do my project over maglev trains, which are transportation of the future. A little bit about the physics behind these maglev trains before I really get into them. The electromagnetism is a big part of these maglev trains, and electromagnetism is the branch of physics that involves the electromagnetic force. The electromagnetic force is a type of physical interaction that occurs between electrically charged particles. And before James Clerk Maxwell published a treatise on electricity and magnetism in 1873, people believed that electricity and magnetism were two completely separate things. And it's when he published this with his findings and everything else that they realized that they acted together to get electromagnetism. So with transportation, it's used pretty much in everyday life just to get you from one duty to the next. You can use bikes, trains, airplanes, cars, and everything else, and they all kind of have a little bit of trouble with them, whether it be traffic jams that occur on your way to work, wrecks that cause these traffic jams, and having to plan accordingly to get where you need to be with enough time in case of all of these difficulties. It's also very dangerous. You have a lot of wrecks and stuff on interstates now, and some people also don't even have the ability to drive. With airports, you've noticed recently that they have become increasingly congested with everyone trying to use them, and with airport security kind of backing things up and all of the issues that are involved with that. So it would be wonderful to have a different type of transportation that could kind of take out some of these difficulties and make life a little bit easier for everybody else. This is where the maglev trains come into place. Maglev trains are also known as magnetic levitation trains. They work by the use of magnets and electricity. They were developed by Central Japan Railway Company and Railway Technical Research Institute, and the research actually began a long time ago in 1970. And down here on the bottom, I kind of have a picture of what one looks like. So how do these trains work? They float over a guideway that is created by magnetized coils running along the track that will repel magnets on the undercarriage of the train, allowing it to levitate above the guideway. And the guideway kind of acts as the rails of what a normal train would have. The magnetic fields interact with metallic loops that are made of conductive materials set into concrete walls. When magnetic fields pass conductive loops, electric current is created to generate another magnetic field. These magnetic loops are used to create a field to make the train hover over the guideway. They keep the train stable horizontally, and repulsion is used to keep the train in the optimal position. These maglev trains float on a cushion of air that eliminate the friction, and these trains can reach incredible speeds that make travel a lot faster. One train in Japan was clocked reaching 310 miles an hour, and as technology and everything increases, I'm sure these trains can get even faster. So they basically work by using three different things. You've got your levitation, your propulsion, and your lateral guidance. This levitation is used to get the train off of the rails. The like poles repel and push the train in an upward motion. You have your propulsion, which keeps the train going forward, and the like poles repel and push the train forward, and opposite poles attract and pull the train forward. You also have your lateral guidance, which keeps your train in an optimal position. And this optimal position is basically just where the train needs to be, and if it were to ever get off track just even a little bit, then these lateral guidance will keep the train back where it needs to be and kind of push it back where it needs to be just to stay in this optimal position. And later I will talk about some of the benefits of this keeping the train in the optimal position and how it can prevent derailments and everything else. So there are two different types of maglev trains. You have your electromagnetic suspension and your electrodynamic suspension. Down here on the bottom, I just have a little diagram of the difference between the two, and I will go into that in greater detail in just a moment. So with your electromagnetic suspension, it uses standard electromagnets. The coils conduct electricity when the power supply is present. Electromagnets attract metal objects with temporary magnetic pull. And this electromagnetic suspension requires a large electrical power source. It requires metal coils that line the guideway, and it also requires large guidance magnets attached to the underside of the train. These electromagnetic suspension maglev trains do not have a conventional engine. They use a magnetic field that is created by the electrified coils in the guideway walls and track, combined to propel the train forward. And these trains that use the electromagnetic suspension levitate between 1 to 10 centimeters above the guideway. The other type is the electrodynamic suspension maglev trains. These were used in Japan, and this is the train that broke the record for the fastest train in the world recently. I believe it was in 2016. It was measured to be traveling at a speed of 374 miles per hour. These electrodynamic suspension maglev trains are based on the repelling force of the magnets. They use supercooled, superconducting electromagnets. They conduct electricity even after a power supply has been shut off. They save energy by doing that. And they levitate nearly 10 centimeters above the guideway. These trains will roll on rubber tires until they reach liftoff speed, whereas the others don't have wheels at all. These wheels can be a benefit if there were ever a power outage or something, or if something were to occur and the train would need to come back on its wheels. They can be compared to the wheels that are used on airplanes before takeoff that will retract as soon as the airplane reaches an optimal height. So here I have a chart that basically compares and contrasts the electromagnetic suspension maglev trains with the electrodynamic suspension maglev trains. The electromagnetic suspension maglev trains are found in Germany, whereas the electrodynamic suspension, like I said, is found in Japan, and that was the one that has been deemed the fastest train in the world. The electromagnetic suspension maglev trains use conventional magnets. They don't need to be refrigerated or anything else. You don't have that issue. But with the electrodynamic suspension, they use superconducting magnets that have to be cooled before they can be used. And the cryogenic method that they use to cool these magnets is very expensive. So that can be an issue. With the electromagnetic suspension, the train is constantly levitated off the guideway, whereas with the electrodynamic suspension, they use these wheels that they use until they're ready for the levitation. And like I said earlier, they may help during power failure. If something were to happen and they lost power, they could come back down on these wheels. And I'm really not sure what the electromagnetic suspension would do in that case. With the electromagnetic suspension, they use attractive forces to lift the vehicle. And this method reduces friction. And the electrodynamic suspension uses repulsive forces to lift away from the guideway. So with the electromagnetic suspension, the distance between the electromagnets and the guideway must be continuously monitored by a computer, and it has to be adjusted if it even moves just a little bit. Whereas with the electrodynamic suspension, they are stable and do not require continued monitoring by computers or anyone. So some benefits of these maglev trains. They are driven by the guideway. Therefore, two trains traveling in the same route can't actually catch up to each other because They are powered to move at the same speed, and some simple calculations and everything else could prevent them from catching up to each other. And there isn't an issue with train derailments. These magnetic forces push the train back into their optimal position even if they move just slightly. There is no need for a driver. Most trains require a driver, but these actually do not. They have a network that has a predetermined destination for them, and they have to go wherever the network has decided to send them. These maglev trains are very eco-friendly. Unlike a lot of transportation that we have now, they don't actually use these fossil fuels to operate. They just use the magnets and everything else, and there's not an issue with pollution, air pollution, anything like that with these maglev trains. Here I just have a quick video of a maglev train running. I'll let it play 1 or 2 times just so you kind of get an idea of what it is like for these maglev trains, and you can just kind of see the speed at which they go, and it's absolutely incredible. So where can you find these maglev trains? There are actually quite a few in the world now. There is one in Shanghai, China. It opened in December of 2002. The highest speed it has been recorded at is 267 miles an hour. There is one in Japan, which I've talked about a couple times as being the fastest train in the world at speeds of 374 miles an hour. There is one in Germany called the Transrapid. It has been recorded going 311 miles per hour. However, in 2006, there was a crash of this Transrapid train that caused the death of 23 people. The train had actually hit a car of some sort. I think a couple of places have called it a wagon that was left on the tracks. So it really had nothing to do with the train. It was still going to its predetermined destination. There was just something that was left on the track that it had hit, and it had killed a couple of people. Now, you can't find one of these in the United States just yet. However, somewhere in California has already kind of been planning on converting the Amtrak trains that they have into a maglev train, and they have said that it would cost upwards of about $150 billion, but they were planning on using some of the funds that they've received from carbon emissions to pay for this, and it would definitely eliminate some of the pollution, like I had said, because these don't actually use fossil fuels. And these are just the sources that I used, and that's all I have to say about these maglev trains. I just definitely believe that these trains could help a lot just because of their fast speeds and everything else, and I think they would be a wonderful addition to have.